Today we will learn direct shear test. Scope of the test. This test is performed to determine the consolidated drained shear strength of a sandy to silty soil. The shear strength is one of the most important engineering properties of a soil because it is required whenever a structure is dependent on the soil's shearing resistance. The shear strength is needed for engineering situations such as determining the stability of slopes or cuts, finding the bearing capacity for foundations, and calculating the pressure exerted by a soil on a retaining wall. Standard reference ASTM D3080 Standard test method for direct shear test of soils under consolidated drained conditions. Significance. The direct shear test is one of the oldest strength tests for soils. In this laboratory, a direct shear device will be used to determine the shear strength of a cohesionless soil, that is, angle of internal friction phi. From the plot of the shear stress versus the horizontal displacement, the maximum shear stress is obtained for a specific vertical confining stress. After the experiment is run several times for various vertical confining stresses, a plot of the maximum shear stresses versus the vertical normal confining stresses for each of the tests is produced. From the plot, a straight line approximation of the Moore column failure envelope curve can be drawn. It may be determined, and for cohesionless soils C is equal to 0, the shear strength can be computed from the following equation. Equipment: direct shear device, load and deformation dial gauges balance. Test procedure: 1. Weigh the initial mass of the soil in the pan. 2. Measure the diameter and height of the shear box. Compute 15% of the diameter in millimeters. 3. Carefully assemble the shear box and place it in the direct shear device. Then place a porous stone and a filter paper in the shear box. 4. Place the sand into the shear box and level off the top. Place a filter paper, a porous stone, and a top plate with ball on top of the sand. 5. Remove the large alignment screws from the shear box. Open the gap between the shear box halves to approximately 0.025 inch using the gap screws, and then back out the gap screws. 6. Weigh the pan of soil again and compute the mass of soil used. 7. Complete the assembly of the direct shear device and initialize the 3 gauges: horizontal displacement gauge, vertical displacement gauge, and shear load gauge to 0. 8. Set the vertical load or pressure to a predetermined value, and then close bleeder valve and apply the load to the soil specimen by raising the toggle switch. 9. Start the motor with selected speed so that the rate of shearing is at as elected constant rate, and take the horizontal displacement gauge, vertical displacement gauge, and shear load gauge reading. Record the readings on the data sheet. Note: record the vertical displacement gauge readings if needed. 10. Continue taking readings until the horizontal shear load peaks and then falls, or the horizontal displacement reaches 15% of the diameter. Analysis: 1. Calculate the density of the soil sample from the mass of soil and volume of the shear box. 2. Cover the dial readings to the appropriate length and load units and enter the values on the data sheet in the correct locations. Compute the sample area A and the vertical normal stress Sn. Sn is equal to A by A, where F is equal to normal vertical force and Sn is equal to normal vertical stress. 3. Calculate shear stress torque using torque is equal to A by A, where F is equal to shear force measured with shear load gauge. 4. Plot the shear stress torque versus shear displacement. 5. Calculate the maximum shear stress for each test. 6. Plot the value of the maximum shear stress versus the corresponding vertical stress for each test, and determine the angle of internal friction phi from the slope of the approximated Moore column failure envelope.